The Rosette Nebula is a beautiful object in space. This stunning nebula, often referred to as a cosmic rose, is a breathtaking sight that captures the imagination of both astronomers and stargazers alike. Its intricate patterns and vibrant colors make it one of the most visually striking objects in the night sky. It lies about 5,000 light-years away from Earth. To put that into perspective, light from the Rosette Nebula takes 5,000 years to reach us, traveling at the speed of light, which is about 186,000 miles per second. This immense distance highlights the vastness of our universe and the incredible scale of cosmic objects. We find it in the constellation Monoceros. Monoceros, which means unicorn in Greek, is a faint constellation located near the more prominent constellations of Orion and Canis Major. Despite its faintness, Monoceros is home to several fascinating deep-sky objects, with the Rosette Nebula being one of its most famous residents. The nebula gets its name from its rose-like shape. This floral appearance is created by the complex interplay of gas and dust, sculpted by the powerful winds and radiation from the young, hot stars at its center. These stars are responsible for the nebula's glowing appearance, as their energy excites the surrounding gas, causing it to emit light. It's a giant cloud of gas and dust illuminated by the stars within it. The Rosette Nebula spans about 130 light-years in diameter, making it a truly colossal structure. The stars within the nebula are part of a young star cluster known as NGC 2244, which formed from the same molecular cloud as the nebula itself. The Rosette Nebula is a captivating sight for astronomers. Its beauty and complexity make it a popular target for both professional and amateur astronomers, who often spend hours observing and photographing this celestial wonder. The nebula's intricate details and vibrant colors are best seen through long-exposure photography, which reveals the full extent of its splendor. Its large size and bright colors make it a favorite target for telescopes. Observing the Rosette Nebula through a telescope provides a glimpse into the dynamic processes that shape our universe. The nebula's bright regions are areas where new stars are being born, while the darker regions are dense clouds of gas and dust that may one day collapse to form new stars. Studying it helps us understand how stars form and evolve. By examining the Rosette Nebula, scientists can learn about the conditions that lead to star formation, the life cycles of stars, and the ways in which stellar winds and radiation influence the surrounding environment. This knowledge not only enhances our understanding of the Rosette Nebula itself, but also provides valuable insights into the broader processes that govern the evolution of galaxies and the universe as a whole. The Rosette Nebula is a stunning sight. Its reddish hue is caused by glowing hydrogen gas. This gas is energized by the intense radiation of young, hot stars. Dark lanes of dust weave through the nebula. These create complex and beautiful patterns. The edges of the nebula glow brightly. This is due to the ionization of the gas. Ultraviolet radiation from the central stars strips electrons from the gas atoms. This process creates the characteristic glow we observe. At the heart of the Rosette Nebula lies a star cluster. This star cluster is a dazzling collection of stars that have formed from the same molecular cloud. The Rosette Nebula itself is a vast region of ionized hydrogen gas glowing brightly in the night sky. It is a stellar nursery, a place where new stars are born. The star cluster at its center is known as NGC 2244, a name given to it by astronomers to catalog and study this fascinating region of space. We call it NGC 2244. This cluster is a prominent feature within the Rosette Nebula, and it is easily identifiable due to its bright young stars. NGC 2244 is a relatively young star cluster, and its stars are some of the hottest and most massive in the galaxy. These stars are still in the early stages of their life cycles, burning brightly and emitting intense radiation. This cluster is home to many young, hot stars. These stars are much hotter and more luminous than our sun. They shine with a brilliant blue-white light, a characteristic of their high temperatures. The intense light from these stars illuminates the surrounding nebula, making it visible to us even from thousands of light-years away. The energy from these stars is so powerful that it shapes the structure of the nebula, creating intricate patterns of glowing gas and dark dust. These stars are responsible for the nebula's glow. The ultraviolet radiation they emit ionizes the hydrogen gas in the nebula, causing it to emit light. This process is what gives the Rosette Nebula its characteristic red color. The nebula is a dynamic and ever-changing environment, with new stars forming and old stars dying. The interplay between the stars and the nebula creates a stunning cosmic landscape that is a testament to the beauty and complexity of the universe. They emit intense radiation that excites the surrounding gas. This radiation is not only responsible for the nebula's glow, but also plays a crucial role in the formation of new stars. The energy from the young stars compresses the gas in the nebula, triggering the collapse of dense regions and the formation of new stars. This process of star formation is ongoing, and NGC 2244 is a prime example of a region where this is happening on a grand scale. The stars in NGC 2244 are only a few million years old. That's young for stars. In the grand scheme of the universe, these stars are just infants. They have a long way to go in their life cycles, which can span billions of years. As they age, they will go through various stages, eventually ending their lives in spectacular supernova explosions or quietly fading away as white dwarfs. The study of young star clusters like NGC 2244 helps astronomers understand the early stages of stellar evolution and the processes that lead to the formation of stars and planetary systems. Our Sun, for comparison, is about 4.6 billion years old. It is a middle-aged star, roughly halfway through its life cycle. By studying younger stars like those in NGC 2244, astronomers can gain insights into the past and future of our own Sun. The differences in age, temperature, and luminosity between the Sun and the stars in NGC 2244 highlight the diversity of stars in our galaxy and the various stages of stellar evolution. These young stars play a crucial role in shaping the nebula and triggering new star formation. Their intense radiation and stellar winds carve out cavities in the nebula, creating regions of higher and lower density. These variations in density can lead to the collapse of gas clouds and the birth of new stars. The cycle of star formation and destruction is a fundamental process in the universe, driving the evolution of galaxies and the creation of new planetary systems. NGC 2244 is a beautiful and dynamic example of this cosmic dance, a reminder of the ongoing processes that shape our universe. The Rosette Nebula is a stellar nursery. This means it's a place where stars are born. The nebula's gas and dust are the raw materials for star formation. Gravity pulls these materials together. As the cloud collapses, it heats up. Eventually, the core becomes hot and dense enough to ignite nuclear fusion. This is how a star is born. The Rosette Nebula shows us this process in action. In this section, we delve into the cosmic winds and glowing gases that shape the nebula. The nebula, a vast cloud of gas and dust in space, is a dynamic and ever-changing structure. These cosmic winds and glowing gases play a crucial role in its formation and evolution. As we explore the intricate processes at work, we gain a deeper understanding of the forces that shape these celestial wonders. The stars in NGC 2244 emit powerful stellar winds. These stars, often massive and young, are the engines driving the transformation of the nebula. Their intense radiation and energetic particles create a turbulent environment, pushing and pulling the surrounding material. This interaction between the stars and the nebula is a dance of cosmic forces, each influencing the other in a delicate balance. These winds are streams of charged particles that push and sculpt the surrounding gas and dust. The stellar winds, composed of protons, electrons, and other subatomic particles, travel at incredible speeds, colliding with the nebula's material. This collision creates shock waves that compress and heat the gas, leading to the formation of new stars and other structures within the nebula. The interplay of these forces is a testament to the dynamic nature of our universe. This process creates the nebula's unique shape. The intricate patterns and structures we observe are the result of millions of years of cosmic interactions. Each nebula has its own story, shaped by the stars within it and the forces at play. The beauty and complexity of these shapes remind us of the vastness and wonder of the cosmos. The radiation from the stars also ionizes the gas, which means it strips electrons from the gas atoms. This ionization process is a key factor in the nebula's evolution. As the gas becomes ionized, it emits light, creating the stunning glowing regions we see in telescopic images. This light allows astronomers to study the composition and structure of the nebula, revealing secrets about its past and future. This process creates glowing regions called ionization fronts. These fronts are the boundaries where the ionized gas meets the neutral gas, creating a sharp contrast in brightness. The ionization fronts are not static. They move and change over time as the stars continue to emit radiation and the nebula evolves. Observing these fronts provides valuable insights into the life cycle of stars and the dynamics of interstellar space. These fronts mark the boundaries where the nebula's gas is being energized. The energized gas at these boundaries is a hotbed of activity, with new stars forming and old stars influencing their surroundings. The study of these regions helps astronomers understand the processes that lead to star formation and the evolution of galaxies. The nebula, with its glowing ionization fronts and dynamic boundaries, is a microcosm of the larger universe, reflecting the ongoing cycle of creation and destruction that shapes the cosmos. Catching a glimpse. Observing the Rosette. The Rosette Nebula is a fantastic target for amateur astronomers. You can see it with binoculars or a small telescope. It's best viewed during winter in the northern hemisphere. Look for it in the constellation Monoceros. Through a telescope, the nebula appears as a faint, fuzzy patch of light. With a larger telescope, you can see more detail. You might even spot some of the stars in NGC 2244. The circle of stellar life. The Rosette Nebula is a dynamic place. Stars are born, live their lives, and eventually die. Massive stars have short lifespans. They end their lives in spectacular supernova explosions. These explosions enrich the surrounding gas with heavy elements. This material can then be recycled to form new stars and planets. The Rosette Nebula showcases the continuous cycle of star birth and death. Beyond the Rosette, unlocking cosmic secrets. Studying the Rosette Nebula helps us understand the universe. By observing its stars, gas, and dust, we learn about star formation. We also learn about the evolution of galaxies. The nebula provides insights into the processes that shape our cosmos. It reminds us that the universe is not static, it's a place of constant change and evolution. A universe of wonder. The Rosette Nebula is just one of many wonders in our universe. It's a reminder of the beauty and vastness of space. It inspires us to explore and learn more about our cosmic surroundings. By studying objects like the Rosette Nebula, we gain a deeper appreciation for the universe and our place within it. There's still so much to discover.
Subscribe my channel of the best universe videos.